Let's demonstrate how to work with a bag of words model. To do this, we'll import pandas and use the count vectorizer class from scikit-learn's feature extraction text module. Scikit-learn is a powerful machine learning library in Python, and count vectorizer is one of its tools for text processing. It transforms a collection of text documents into a matrix of token counts. In other words, it breaks the text into words or tokens and counts how often each word appears. This gives us the numerical representation we need to apply machine learning techniques to text data. Exactly what we need. The data that we will be using for this example consists of 6 random sentences stored in a variable called data. Creating a bag of words is straightforward. The first step is to initialize the count vectorizer class. We'll store it in a variable called countVec. At this stage, we're not passing any parameters, so we just use empty brackets. This sets up count vectorizer with its default settings ready to learn the vocabulary from our text data. The next step is to apply count vectorizer to our text data. To do this, we call the fit transform method on our variable countVec. Fit means that count vectorizer looks through the text and learns which unique words appear in the data. Transform then converts the text into numbers by creating a matrix that counts how often each word occurs. By using fit transform, we combine these 2 steps into one line of code. Now the variable countVecFit holds our bag of words representation, a numerical version of the text. To visualize this representation as a table, we'll convert it into pandas data frame. So we initialize a new variable, and after the equal sign, we use pd.dataframe. In the parentheses, we apply the toArray method on our countVecFit variable to obtain a regular 2-dimensional array of numbers, which can be placed in a data frame. This way, every row will become a document, and every column a word from the vocabulary. The entries will show the word counts. To label the columns, we use the method getFeatureNamesOut from our count vectorizer. This method returns the actual words in the vocabulary that count vectorizer learned during the fit step. These words become our column headers, so each number in the table can be clearly linked to a specific word. We can then print out this bag of words and see what it looks like. For each of the rows, this represents a different piece of text within our data. For example, row 0 is the text. Most shark attacks occur about 10 feet from the beach, since that is where the people are. We can see here that the words 10, about, are, attacks, beach, where are all present within this text. The next row down is just the next piece of text within the data. Each row relates to each piece of text in our data, and each column relates to one of the individual words. The values show the frequency of occurrence of each word in the document. By the way, if we want the table to indicate only whether a word is present or absent without actually counting how many times it could be found, we can do that too. Count vectorizer has a parameter called binary. By setting binary equals true, every non-zero count becomes a 1, which gives us the simple word exists or not version of bag of words. The bag of words method is quick to build and straightforward to understand, but it has an important limitation. It only counts words. It doesn't consider their order or how important a word might be compared to others. So, while useful as a first step, it loses much of the context of the text. In the next lesson, we'll explore the TF-IDF vectorizer. This method still represents text as numbers, but it also considers how common or rare a word is across the whole dataset.